next level is where robot uses millions and millions of virtual episodes to learn and confidently acts in the real environment. Embodied AI and use cases that mature first. Let's hear from Director of MyEdu Institute, Jeffrey Chuan, with a report on From Service Robotics to Embodied AI, Evolution and the Future of AI.
Good afternoon, ladies and gentlemen. So I'm Jeffrey from Lattel Robotics, Malaysia. So I'm very glad to be here today, and I'm even more happy when I saw the robots. So you still remember the humanoid robot that is locally made here in Russia. And it excites the crowd. And that actually excites me even more. Why? Because my presentation is very similar to what excites you. So I believe that you will like it. Right, so this is my topic, right? It's a bit technical. So from service robot to embodied intelligence, the evolution and future direction of artificial intelligence, all right? So in simple terms, I'm going to show you like over the year, AI has been transforming robotics research, right? And together, they are actually making wonderful things, as you saw in the previous presentation, that actually a lot of this robotics technology, once we add in AI, and it come out wonderful things, like what you saw just now in the autonomous car, okay? So I'm going to show you more, because that is what the stories that I'm going to share with you. So I'm going to start to turn back a few decades back to show you some background. So when I mentioned robotics maybe like 15 years ago, so everyone will talk about the one on the left-hand side, right? So that is basically robots in factory, okay? So we call it industrial robots. Okay, so the peak, it actually like somewhere in 1980s, where we use a lot of robots and increase our productivity. So it is a good creation of humanity, and it brings a lot of value in our life, right? But it actually do very repetitive thing, all right? So what I can say is like, it is good, it is fast, it is strong, but maybe not that smart, right? So AI come into the picture, right? So somewhere in between 1980s to 2000. So we start to think of like how to make robot more intelligent, okay? So we have another new domain of robots. So we call it service robot. So we can compare between these two on the left and on the right-hand side, right? So the service robot basically do something out of what it's supposed to do, because in this video, the robot is basically not cleaning a robot, but instead it is actually interact with the customer, which is this condition never happen in industrial robots, right? Because industrial robot is designed exactly what it's supposed to do, and that's it, right? But for service robot, it actually go beyond. And it start to interact with human, okay? Of course, the first concern is safety, but how to interact with human, especially when the robot's supposed to do something that's out of its scope. Like, Roomba is not designed to play with babies, right? Okay, so that interaction actually require a lot of intelligence, and that is where AI come into picture. So this is where the direction of my presentation today. So we can see after we have the Roomba, which is a success story of service robot, then people start to think like, what else that we can do? So we start to add more and more intelligence into robots, and we create more and more smart robots. So we can see from intelligent robot research that happen throughout the year, throughout the world, we can see a lot of robots start to get smarter, start to get better, and also we create a lot of new services. So for example, in elderly care home, right? So, or in like children home, etc. So there are a lot of facilities that require human care, but we are lack of this human labor. Okay, previously it is done all by human labor, but now we have robots start to take over the position because it slowly acquire the intelligence that it can really fulfill the scope of the job, right? So as you can see also in 2020, we have COVID that make a pause of the world, but that actually make a big push to robotics that we have seen, like for example, delivery robots. So robots start to help us to deliver our stuff. Not only deliver food, medicine in hospital, and also a lot of other things. For example, in hotel, they start to take orders, in restaurant, and not only just basic needs. As you can see on the right-hand side, lower, we have very fancy things like robot restaurant. So today we can see there are actually a lot, like, for example, robot is making latte art for your coffee, right? And it's actually making much better than normal human being, right? So we can see once we add the intelligent part into robots, this service robot actually can give good service to us human, right? So that is basically the growing part. So now, how we actually go moving forward from there. So a little bit background that I actually did this like 15 years ago. So when I joined this competition called RoboCup at Home. So it's a competition, it's a worldwide competition platform that is designed to call upon all the scientists, all the researchers around the world that we discuss in a competition manner to see what or how we're supposed to design our next generation of service robot, or the robot that help us in our home environment. So actually, without realizing, I'm actually into what we call the embodied intelligent research direction. So from there, we actually have, from service robot, now we are talking about embodied intelligence. Okay? So this is the competition setting. So as a comparison, when I'm building the robots, we can see that the robot actually have very similar component as a humanoid robots, or what we call it embodied environment, embodied intelligence. So I roughly divide into these 5 parts. So you can see the robot brains, okay, which is, well, you have the robot intelligence plus the AI, which is, it involves all the AI, machine learning, cloud computing, big data, etc. Right. Then we have the eye, okay? The eye, like just human eye. So we use AI to make robot can see better, just like how human being perceive the environment. Then also we have the mouth and ear, which is like we give the capability using AI for the robot able to communicate with each other like us, human, communicate with each other. Right? So that is the human-robot interaction. And of course, robot arms, which is the object manipulation. So that is where we have physical interaction with our environment and with other human beings. And lastly, of course, this one pretty much presented in the last presentation, which is the robot leg, which is the autonomous navigation. So now we know that robots actually able to navigate not only outdoor, but also in indoor environment that it can move around, just like us human. As long as we have the maps, as long as we have the coordinate system and so on, which is today we have all the sensors that help us to do that. Right, so these are all the components that slowly build up the embodied intelligence. Okay, so from here, I would like to show you some example. So for example, like in vision, over the year, you can see, slowly last time I still remember when I was in school, I used very primitive way to make cameras, to take photos, and to understand what is happening in the environment, do pattern matching and so on. But as AI grow or AI advance, today we have machine learning and even deep learning. For example, on the left-hand side, we have the deep learning model that actually help us to, in real time, understand what are those things in front of you, right? And this thing can be trained to get very high accuracy that we can use it in the industry. So for example, in the automated visual inspection that show on the right-hand side. And this technology actually keep on advancing because today we have what just mentioned in the previous presentation, the VLM, visual language model, that we don't even need to train, right, for a particular case, but now if we can just connect to those big VLM that is available, our robot can just understand what an apple look like, right? Or what a bottle look like, etc. So it actually goes very far with AI. Then the second thing is human-robot interaction. So if you still remember in the slide that I show you the Roomba, which is it play with the babies, so that is a very primitive interaction, right? But today, the human-robot interaction is getting very complex, as you can see on the left-hand side and also on the right-hand side, whether it's in a domestic environment, like an old folks' home, or in a technical factory environment. So this robot actually have a lot of intelligence thanks to our large language model that it can actually interact. Also, we have very excellent speech recognition and speech synthesis technology that enable this robot able to communicate very naturally with human nowadays. Right? Even maybe now you might realize that you don't actually feel weird talking to robots anymore. Right, so we can see AI actually bring forward this human-robot interaction, and I believe in future it is not weird at all when human starting to communicate a lot with with robots. Right, so maybe I can also say that maybe some of you now actually can have a very lengthy chat with ChatGPT or something like the Giga Chat, right? Right, so of course the next thing is manipulation, so physical manipulation. So we have this mobile manipulation. So in factory, when we want to do some pick and place, it is very simple because everything is controlled. We have precise measurement for everything. But in a home environment, it is a totally different story because your fork, your spoon, your plate in your house and in your neighbor's house are totally different. So how to actually precisely can manipulate all these objects require very high intelligence, and that is where AI come in. And not only for mobile platform, and even we can actually put on Lego robot that now manipulation done by robots can actually reach a lot of difficult challenges or tasks in mobile manipulation. So thanks to the AI that come into picture. Right, so of course, this is the parts that I don't need to explain more because the previous speaker have already told you a lot of stories. So with the autonomous navigation technology that we have nowadays, robots start to able to navigate. It start to able to drive car. It start to able to bring us to everywhere because it knows its location, it knows the maps, know where to go. And this thing can also be applied indoor, outdoor, or anywhere, right? So robot now is safely can move around thanks to the technology and also thanks to the advancement in AI. And even now, we also talk about using large language model to make robot able to move somewhere with a very vague input. For example, like please go to, please bring me like a water, right? So for example, then the robot will understand like where to get the water, etc. So yeah, pretty much the navigation part is already solved, thanks to the advancement of AI that is bring the robotics into another height. Okay, but last but not least, of course, is the brain. So we have robot intelligence previously, but now with enhancement of AI, then we actually open up a new domain. So as mentioned by the previous speaker, we have this what we call the VLA, visual, language, and action. So these are the three parts. So similarly like LLM, so we try to find the relationship between words. So over here, VLA, try to find the relation between visual, which is the images, language, which is our description in language, and also action, like how we do something, right? For example, how you eat, how you walk, how you do something, how you tidy up the dining table, etc. So we combine all these things and we use the LLM technology, we use the transformer technology to find the relation between that. And that actually helps us to teach how robot able to perceive the world and do some action so that it can complete some tasks. So over here, VLA model is actually an AI model that integrates vision, language action that enable robot to understand natural language command and execute tasks in real world. But of course, this is a very new research and state of the art, and now a lot of debates still talking about world model, how we should perceive, how we should understand our world, and so on. And I feel that this is a very interesting research direction that's going on from now onwards. Right. So let's come back to humanoid robots. So I show you a lot of this, how AI actually empowered robots so that we can achieve what we call the embodied intelligence. So when this thing we apply into a very special species of robot, which is the humanoid robot that look like human, so ultimately it comes to what we actually dream on, maybe last time when we start to build robots. So as you can see, these are some of work that I collaborate in Japan, that they start to build humanoid robots to help in the production line. Okay, so over here is the food production line. So over here, okay, so just to confirm, the one in the middle is robots, and then the one on the left and right hand side, they are robots. Okay, right. So it looks very similar now. So this robot able to actually share the load, try to understand how humans pick up the ingredients so that they can assemble into a box of food, right? So that is, I think, like the first step that we try to introduce humanoid into a real use case that provide productivity or provide real value in an industrial setting. But of course, ultimately, we hope robot can actually help us doing our whole housework at home. I believe that is what everyone that talking to me, they are asking me when the robot is going to help us to like do their laundry, prepare their meal, and so on. I believe everyone is asking that, right? So we are working on that. And now we almost have all the ingredients assembled, and I believe in near future, this is a very exciting development that is going to happen. Yeah, I really hope so, and we try to work hard for that. So you can see with this platform, we try to work toward this to make it a reality. But the last part of my presentation today, I would like to show you another new domain, okay? So we have robots that are able to move around like human, and in fact, it is getting much smarter, much agile, much dexterity, higher dexterity, etc. over the day. Right, so as you can see, the robot in front of you in the video. And it is basically getting much stronger because like it can fall down, just like normal human being, but it can actually come backwards, right? Just like human. So with that, maybe another domain that humanoid robots can go into is sports. So we try to put this robot into soccer field and start to play soccer. Right, and with that, we actually open up a lot of new things that we are very excited to explore. For example, it provides new form for research, development, and also education. So we can see the full body motion, okay? And also, if you want to play football, it is a multi-agent task. So a few embodied agent is going to fight against another team, right? So it is a very high level. And also, the perception, the localization, and the soccer game is a very exciting thing. So we have done it for the past few years, and we put it in such a way that we want to see how far this thing can go. And surprisingly, it actually gives a lot of very exciting result, as you can see. So this video is the real video that we take, okay, with no teleoperation, okay? And the robot just fall down, and then it go back up, and it continue the soccer game, just like how we teach our young children to play soccer. Okay, so this is a very interesting future that we really look forward into it. I can see that when we do this, it actually create not just a simple soccer game, but it's a new world of sports and entertainment. Because for the past 2 years, we do this. We have attracted a lot of sponsors. The venues are put, tickets are sold. We have hundreds of millions of views online, and more universities team are actually creating. Right? So we become a new ecosystem for sports or robot sports. Okay, so today it is just the very beginning. Over here, I would like to bring you this message that towards the new horizon of humanoid robot with embodied intelligence, let's build the future together. With that, thank you. I'm Jeffrey from Lattel Robotics, Malaysia. Oh, by the way, this is the dance move by Michael Jackson. Just so you saw the moonwalk, right? So that is what we try to make the robot able to do it, etc. Okay, thank you very much.
Thank you, Professor Tan. Thank you. Now we know that future of artificial intelligence is in a good hand. Thank you very much.
Thank you. Thank you.
Jeffrey Chuan.
Jeffrey Chuan. A round of applause again.